pandemic disrupted the education sector, of course in all the obvious ways, but also new problems emerged for international students, and long-time problems like plagiarism took on entirely new forms under a remote learning setting. In today's interview, Mouhamed Abdulla shares a post-pandemic perspective on these topics.
My name is Mouhamed Abdulla. I'm a professor of electrical engineering at Sheridan College, and Sheridan is a school located in the Greater Toronto area.
Can you elaborate on what your PhD was in?
It was really in electrical engineering, and my focus is in wireless communications.
Well, with that background, how did you get interested in the topic of remote teaching during the pandemic?
Well, as you know, Kyle, primarily one of my key responsibilities at the school is to teach. In addition to research, committee work, and all that, teaching is a big chunk of what we do in our day-to-day work. And we went through this incredible once-in-a-lifetime experience with this pandemic. And we had a discussion with few colleagues that perhaps we should record this. Perhaps we should reflect on what we went through. It was very sudden, but we didn't really reflect on it. So it was really a way to record all that we've been through in a formal document. And that's why we wrote this book chapter that is currently published.
Well, before we jump into some of the differences post-pandemic, what was teaching like pre-pandemic?
Well, teaching pre-pandemic was, as you would imagine, we go to school, we have lectures, like this is the norm in engineering schools and with other schools. We have physical labs. And although we do have certain components in our school where online learning did exist pre-pandemic, but we were not involved in online learning. I wasn't involved in online learning. The majority of my colleagues were not involved in online learning. So for us, it was a sudden jump to something that is totally uncharted territories for us. We haven't used perhaps some of the tools that we're using right now. We've never experienced the applications and then the processes and then the guidelines that we're applying right now. And so for us, it was all new stuff that we had to learn while at the same time teach. It felt like we were students while at the same time we were a symbol of authority and teacher and professors and the classroom. So it was, to be honest, quite a steep learning curve for us.
Well, you'd mentioned even if you hadn't been involved, there was some effort at the university for online learning. Was that kind of a turnkey solution you could step in and just work with? Or what was the state of the online learning prior to its sort of urgent increased need?
I have to admit, we do have many of the tools pre-pandemic. The LMS tools, the learning management tools, they did exist pre-pandemic, but quite frankly, it was underutilized by faculty members. I cannot speak for everybody, but certainly for me and some of my colleagues, we didn't really use it to its full capacity. These LMS tools that exist, that many universities and colleges use, are remarkably powerful. You could do exams in them. It's an interface between the student and all the learning that happens. Exams could be carried over the LMS tools, evaluations are done there, assignments are uploaded there, group interactions are done through that, chatting, and other features. But none of these features were things that I personally use. We just use them to upload assignments, to give the grades, and that was, to be honest, the extent of our interaction with these learning management tools. But then when the pandemic hit, we had no choice but to use them to their full capacity. They were at some point clunky and not fully efficient with some aspects of these tools, but the companies with which we work with, in our case, we used Desire to Learn, Brightspace company. It's a Waterloo Canadian company that exists. And they were very responsive to our needs, and they helped us a lot with updating their application and making it more efficient and easier to interface and to work with.
Was the limited adoption prior to this, or at least not at the magnitude certainly these LMS tools get used today, was that just because it was new and people were set in their ways? Or is it really, a poor facsimile for the way things were done and we use it now primarily out of necessity?
And again, I cannot speak for everybody. I could speak for myself and a subset of colleagues that I interact with. We didn't use them because we didn't find the necessity of using them. Exams were just printed on papers and we would give that to students. Students would do their evaluations on paper. We would collect the papers and then grade them. We didn't use the online capabilities. Now, I have to admit, other schools schools within our college did use these LMS applications to perhaps greater extent. And so it's difficult to force faculty members to adapt to new technology. Just to clarify, the technology was there. Perhaps we didn't find the necessity to use it. And perhaps that's the key thing to remember. When the pandemic hit, we had no choice. And like you said, we absolutely had no other alternative but to learn how to use these technologies and to learn how to use them. And today, now that we've grown after using these different features of LMS tools, we could totally see how they're more efficient. They're not a solution to everything. There's always limitations and there's always issues with these LMS applications and tools, but they're certainly more efficient if used in a smart and effective way.
And I'm curious if you can articulate some of the challenges moving from the traditional learning environment to a remote. Some things were probably easy, some things were harder. What stands out as some of the more challenging aspects?
Plagiarism is a big one. It's a huge problem, especially in engineering schools. We do have certain features that are built in with these LMS tools that allows us to monitor their facial activity. So there's cameras that are turned on, the microphone is turned on, facial detection feature is there, Turnitin is used. Turnitin is a feature that is used to detect if written word were plagiarized from other sources. But despite all that, there's always ways where students could find ways to cheat and to plagiarize. And I cannot generalize and say that this is happening across the board, but it does happen. If you have a camera that is turned on, but then the camera is not showing the full extent of a student's hand and paper and desk and face and all that is hidden, well, certainly they could have other resources around to help them with equations or to help them with certain cheat sheet and whatnot. And so these are some of the issues that are more pronounced. And then, of course, there are other issues of remote education, particularly for engineering. One of the key limitations of online education is how do we do labs? How do we do engineering hands-on labs remotely? That was a big challenge for us, and we had to seriously take the time to reflect and think and brainstorm with various colleagues, and we had to buy equipments and then figure out how do we keep the same level of hands-on learning that we take pride in what we do day to day when we're at home. And that was, if you ask me, that was even bigger than the plagiarism issue.
Yeah, I'm curious what some of those hands-on projects were. I know I remember doing some circuit and breadboard stuff when I was in an engineering program that I really enjoyed, but what's the breadth of what you wanted students to be working on?
That's correct. So for me, I teach different courses. I'm kind of lucky, but also it's difficult to teach different courses. So I do teach some of the courses that doesn't require a breadboard, doesn't require any circuitry. It's just math, basic fundamentals. And for that, it's online teaching, it's fine. You could certainly do that. But for courses where you need different equipments, like you mentioned, if I teach a course, electrical fundamentals, in this course, well, students need to be in the lab. They need to use a power supply. They need to use a digital multimeter. They need to use different equipments, resistors, capacitors, transistors, and other equipments. They need to have access to these different equipments. Breadboard and things of the sort, they're not that expensive. So we, in fact, did prepare kits for our students, and students were able to come into the school. They grabbed their so-called kit of all the different equipments, including the breadboard. And for DMM, digital multimeters, well, we recommended that they buy one from a local store, different stores that we have here, Home Depot and others. And so in that sense, they were able to manage. But if you go to more advanced courses that are near completion of their engineering degree, wireless communication courses, at that point, we were in a serious problem because in these more advanced courses, well, we need an oscilloscope, and that's a very expensive device. We need a waveform generator. That's an expensive device. We need more sophisticated digital multimeters, RF generators, and real-time spectrum analyzers. These are all expensive and heavy. It's not easy to have that in a remote fashion. So for these different challenges of teaching wireless communications, we seriously had to think in a deep way to figure out, well, what do we do in this case? We can't just rely on simulations. And although we do rely on simulations, I don't think we should underestimate the power of simulation, but that's also limiting. At the end of the day, engineers should also have practical, hands-on experience with different physical equipment, not just simulations. Simulation is good, but sometimes it's idealized scenarios and it's not sufficient. So we really need to complement simulations, which we certainly did, with hands-on work. And this is where we had to figure out out what's the replacement for a spectrum analyzer? How can we continue the learning of wireless communication without these equipments? And we had to find different ways, and we had to redraft the labs, and it was seriously time consuming. If you ask me, the teaching part was possible. We did it in both ways, synchronous and asynchronous, and that we managed. But then the labs were kind of a bottleneck for the challenges of teaching because we had to redesign these labs from zero. We really had to begin from zero and then to figure out how do we ensure that the concepts is learned in an effective way.
Do you have any key takeaways from that process that maybe another educator could benefit from who's doing similar adaptations?
I think some key takeaways is that everything is possible. If we're forced to do it, I think humans have the capacity to innovate. And sometimes I will speak for myself, we underestimate our capacity to actually make a program very efficient and solid if we seriously think about how to do that. I mean, for us, when we had the problem of wireless communication equipments, well, we then went and figured out different applications that people could download from the Google Play Store and have them on their phone. I designed a lab where students were asked to, in fact, play with their home router and figure out the different settings, the frequency, the channel, the power transmission, and all that. And through these equipments that they have around them, we were able to still keep the quality of learning in an effective way. And to be honest, in these wireless communication courses, my students really enjoyed these labs because it seriously impacted the way that they see their own network and how they could optimize their own indoor at-home network. So my recommendation to other instructors would be to read. If you look at resources online, a lot of people publish their experience in teaching. Not all published work is good, but many of them is good, and you could certainly learn that way. Another way is to really discuss and brainstorm with your colleagues. Colleagues are great because every faculty member will have a certain viewpoint of how to improve or how to tackle these learning challenges while being in a remote situation. And the collection of all these different discussions and brainstorming, this is how one is able to come up with effective learning mechanism.
Having observed it firsthand, can you talk a little bit about the different responses you saw, specifically from the point of view of an international student?
In the teaching, we faced different challenges. One of these challenges was the difficulty for international students to travel and to come to our campuses. We have some 20% of our students that are international, and we have some 110 countries that are represented at Sheridan. And many of these students could not come in. They could not obtain visas. They could not land or obtain the approval to travel to Toronto. And so we had different challenges. One of the challenges was the time zone issue. At some points, I remember teaching a course where I had students in the Philippines. I have a few students in India, a student in Dubai, and another student in Colombia, and the rest of my students in Toronto. So teaching at a specific synchronous way where you have people spread around the world at different time zones was also challenging, and particularly with exams. We had to ensure that all exams be done in a synchronous way. So sometimes people had to do exams very late at night. We had to somehow make it work for the majority of students, but some of them had difficulties with that. And so we tried as much as possible to accommodate certain students that were located around the world that were taking our courses. So I think this is also something that is interesting that we observed, and we tried as much as possible to be compassionate and to be accommodating with these international students.
Thanks to our sponsor, Neptune.ai. 99% of machine learning teams are doing really awesome things at a reasonable scale, with maybe 4 people and 2 models, not necessarily 100 people and 1,000 models. Yet most of the industry best practices come from the handful of companies operating models at hyperscale. The folks at Neptune.ai want to change that by sharing insights, tool stacks, and real-life stories from the practitioners doing machine learning and ML ops on the toughest challenges, distilling their findings for everyone. They even built a flexible tool for experiment tracking and model registry that will fit with your workflow at no scale, reasonable scale, and beyond. Check them out at Neptune.ai. Well, from reviewing the figure in your paper, which has the daily trends of COVID-19 cases for province of Ontario, Canada, it's very clear you've had 3 major waves, at least at the time of publication, and that crosses many different terms for the school year. So you've got a couple of cohorts in there, and I guess you could compare as well to cohorts prior to that. Do you have any observations about the evolution of those cohorts? How have students adapted to the changes?
So to be honest, at the start of the pandemic, it seems like they were lost as well. Not to say that we were entirely lost. We were initially in a panic mode, but then we found our way. But students were also uncertain of what's going on. There's a lot of anxiety that went through this period with students. We do have a lot of international students, and many of our students were lonely. They couldn't see their friends. Their family is not here. Many of their families are in different parts of the world. They're not here. Anxiety, depression, loneliness, all these problems were kind of brewing at the start of the pandemic. So as much as we can, we try to be compassionate, considerate, and kind of offer a sense of community with our students. But in terms of the trends that you mentioned, this is correct. So we went through this remarkable experience over 7 semesters so far. So 5 semesters from what you have in that book chapter that we recorded from the onset of the pandemic in mid-March 2020 until July of 2021. That's what we have on that graph. But then if you look at today, we're really 7 semesters into this pandemic. And so it was difficult at the start for our students, but then the students really understood how the process is working. They learned the different mechanisms and the different tools that they have to consider when they submit assignments, when they come to classrooms. But at the same time, there's always limitations to that. One of the key challenges that I noticed with students is that it was hard to know if they're participating in an effective way. Sometimes students are too shy to discuss or to talk in classrooms, although we have cameras and we have microphones and all that with these different teaching platforms, but they don't interact. They do not turn on their camera. They feel perhaps reluctant to share a comment on the chat feature of it. So these aspects were a bit tough. I mean, you go to a classroom and you talk, and it's hard to know if there's anybody listening to these discussions because students are just not interacting. And so these were also some of the challenges that we had to kind of nudge them a bit or have exercises where they're forced or encouraged to turn on their camera and then to interact and to have discussions. And then at that point, we saw some amelioration in these online interactions.
So we're now in a state, I don't know what your exact local policies are, but everywhere's a little different in terms of being back partially on site or fully on site or hybrid modes. Where do you stand today in the process?
It's interesting that you mentioned this. So to be exact, for us, the pandemic complete state of emergency began in mid-March of 2020. And now we're around the same period. We're not mid-March, but we're in early parts of March. And the mandates are terminated. We no longer have these strict mandates, and they just finished a few days ago. And so now we're gradually going back on campus. In fact, on Monday, 2 days from this recording, students are expected to be on campus. Not all courses will be offered in a face-to-face fashion, but they will be on campus. And many of the programs that we have right now are mostly either fully remote for courses that doesn't require labs and things of the sort, math courses and others. And then for the others, the courses that do require labs and interactions with equipments and labs that are impossible to bring or do at home, well, we have the hybrid model that is in effect. And gradually, the objective is to move to a pre-pandemic state. I think if you look at the entire 2-year period, right now, as it stands, March of 2022, we're as close as possible to a pre-pandemic as we've ever seen during these 2 years.
Do you imagine then that the objective or the trends will be to just kind of resume course where we were, or are there lasting learnings and impacts that remote teaching has kind of had and will stick around in this topic and will have a longer lasting effect?
This paper's title is Remote Teaching and Learning in Applied Engineering, a Post-Pandemic Perspective. So the goal of this writing was really to say that although pandemic is near the end, when we wrote this, we thought it's near the end, but it wasn't. We stayed another year until now. But we believe that many of the lessons that we've learned will continue. We do see the benefit of hybrid education. Hybrid is not going anywhere. I think people saw the flexibility of hybrid learning, both faculty and students. There's certain flexibility with hybrid learning and certain benefits to it. You don't need to commute. You could listen to a recording of a session even if you miss it because you have some family obligations or some transportation challenges. So there are different advantages to hybrid learning or to remote learning. So I think ultimately the way that we envision it, and we have this in one of the figures, I believe figure 2 in that book chapter, where we give a spectrum of no pandemic to peak pandemic, and we break it down into no risk, low risk, medium risk, and high risk. And then we give a breakdown of a recommended split between face-to-face and virtual delivery. And so even if we go to a state of no risk, we still could imagine that perhaps 25% of learning could still happen in a remote fashion. And not everything should be on site. This relieves us from many of the challenges of being on site. I mean, one of the challenges that perhaps I could mention is we have always a problem with facilities. We have a lot of students and not enough classrooms and not enough lab spaces. So if we remove the teaching to a remote education and then keep the on-site for necessary items like labs or face-to-face interactions or brainstorming or presentations, things of the sort, well, I think it makes it much easier for managing a large cohort of students on campus. So ultimately, the view is that we do want to keep a certain amount of online learning in addition to face-to-face learning.
And could we touch on plagiarism, which you mentioned as a problem? I know this is kind of a hard statistic to know because you don't really have ground truth, but did that become a persistent issue, or was it sort of the same background as you saw previous? What are trends in this statistic, if you can infer what it might be?
It's not statistics that we have in terms of plagiarism, but we do use different learning management tools. Within these LMS tools, facial detection technology is used. They use certain AI features where they could detect if a student is looking on a different site. And through that, we could kind of detect that plagiarism is happening. And of course, we also use other type of plagiarism mechanisms like Turnitin. And Turnitin is a powerful tool, especially for handwritten work. It is able to kind of sift through the entire write-up of a student's work and to detect where certain paragraphs or certain sentences were captured. So these are some of the different mechanisms that we use. And to be honest, the rest is just us being able to detect as instructors, like the old-fashioned way of looking at different assignments and seeing if the same silly mistake is repeated on multiple papers. Then you could certainly imagine that possibly plagiarism did occur. And on top of all this, there's also plagiarism of hiring somebody. So a remote exam taker could be hired to take the exam on behalf of students. And this is also another problem. We do have mechanisms where students need to show a photo ID at the start of an exam with their face on the camera. But then, there's always workarounds around that. And students, unfortunately, do use these features.
Are there areas that you think about or are actively working on where you think there's opportunities for educational innovation?
In terms of educational innovation, I think certainly the aspects that we saw in terms of kind of go back to these wireless design courses that we've modified. And we use different equipments that we haven't used before. Certainly applications that people can install on their phone and that allows them to understand the quality of the signal. This is something that perhaps we didn't use pre-pandemic. And now that because of the pandemic and because of limitation of not being in the lab, we started using them and we saw how beneficial it could be. Labs where we ask our students to play and to configure and to change the signal of their Wi-Fi router at home were things that we did not use in the past, but we did use it in the past few semesters, and it was very instructive for students. So we do see that relying on cheap, off-the-shelf, often IoT-based equipments should not be underestimated. Some of the hobbyist equipments that exist out there that are not that expensive, they're very instructive in the sense that people can learn a lot from them. They could tweak it, they could play around with it, they could reconfigure things, they could measure. So the reliance on heavy, expensive equipments may not always be possible, and these hobbyist equipments are not so bad. Students could still learn a lot from them. I think that was very insightful for me and for some of my colleagues that work in this area. And I'm sure other faculty members working in other disciplines could find parallels to what I just discussed as well. But then again, one has to also be realistic. Not everything can be taught in a remote way. And there are limitations, and that's where lab-based will be necessary. And if it is necessary, well, we have to do whatever it takes to have our students back in the labs in a safe way for them and also for the technician, technologist, and also the instructor.
And I think you've mentioned a few times this work we've been discussing is a chapter from the book. I think it's a scholarly text too. Can you talk a little bit about the book and who the audience is?
The book is mainly written for, I think, educators, but also people interested to learn about the whole process of education and the future of education. Education is going through different phases. And I think this pandemic forced us to really innovate as much as possible. And all the instructors that we have around the world try to innovate. So this book has a few chapters in it. We're featured in chapter 9, but you have different experiences from people in Australia, Finland, and Germany, and Hong Kong, and China, China and Malaysia and Morocco and the UK and Pakistan and other places. So I think it's a nice collection of different perspectives from different countries of how they approached their teaching during the COVID-19 pandemic period. And I think it's a nice collection of work. The book is published by Springer Nature, and it should be available around April of 2022.
Very cool. I'll have some links in the show notes then for listeners to follow up. Mouhamed, thank you so much for taking the time to come on Data Skeptic and share your work.
Thank you so much, Kyle. I really enjoyed it.
That concludes another installment of Data Skeptic Physically Distributed. Thanks to our sponsors today, Neptune. Myself, Claudia Armbruster, as associate producer, Vanessa Bly, guest coordinator, show notes written by David Abembe, and our host, Kyle Polich.